Kia ora. As a quick intro to this video, we had a morning tea technical deep dive session here in Wellington. The focus is rather in the weeds, looking at Lakebase and Apps. Senior Solution Architect Barry, also here in Wellington, decided to pull some publicly available data to show what you could do on the platform using Lakebase and Apps. So here we go. Thanks for being curious. Thank you kindly for being here on this gorgeous, gorgeous Wellington morning. Without further ado, Mr. Barry Hodges, man of the hour. He's a senior solution architect. He's partner in crime, also strictly across the public sector.
Is who was alive in 1999? All right, everybody just about. All right, well, I was. And look, if we think back to 1999, just to give you a little bit of a sense of grounding this particular year, we were all obsessed about Y2K. I was, with the job I had. Matrix had came out, the very first of those movies. PlayStation was just about at the end of its era, and PlayStation 1 was literally around the corner. Nokia 3110, best phone in the world. We were still using these things quite a lot. Europe went Euro, Furbies are cool, and Helen Clark got elected to Prime Minister, so that was awesome. And by the way, we clipped 6 billion people, according to somebody, and now we're over 8 in only 26 years, so it's a little scary. Now, why am I talking about 1999? Well, it was my first job in what I would call pure data related role, and I got it at Oracle. And in my job, I was here in Wellington. I had been working with Oracle databases in my previous role, but I was just interested in the technology, not the application I was actually officially there to look after. I read the Oracle documentation stack, taught myself Oracle, and then started applying for jobs. And I had about 40 rejections. But ironically, of all the companies to give me a job, purely based on theory, was this company. And my job was as a support engineer, and I was given my own personal stack of Oracle documentation instead of having to nick them from the DBA that I was working with. A stack of Oracle floppy disks, 7.3 by the way, was the glory days of Oracle. They've gone downhill since then, in my opinion. A laptop that probably weighs the same as my Mac, but on a slightly different form factor, and my blessed 3110. And I was sent out to customer sites to do Oracle stuff. I was in support, but I was on site Oracle support. And one of the many jobs I had to do was to set up databases. So that's what you were brought in to do. You want a database created because of, and it was one of many things I did, but it was something I did quite a lot. And my first question was also, what are you going to do with this database? What's its primary purpose? Because it really fell into one of two categories. It was either going to be used to run OLTP or OLAP based processes. They were the two database types that we were dealing with. And why did this matter? Because when the database got created, how I set that database up was fundamentally different. Same software, but the configuration was very different. Think about a table, logical table. We know these things intimately. Rows and columns. So I've got in this one a very simple table, 3 columns, ID, value, and currency with 5 rows. Now there's 2 ways I can store this, and this is first of all to store it by row. So one block, and this is when I say block, this is where the data we physically stored on disk. I would put all the values for row 1 in block 1, row 2, block 2, and so on. So everything was contiguous on that same physical block. Why did this matter? Well, start thinking about how you're working with the system from the perspective of transaction database versus an analytical database. If I am doing transactions, and if you think about what a transaction database is being used for, it's one person updating one record, selecting one record, deleting one record. So you were doing typically get that data into the application and work with it. So it was very efficient if the data was put together in a block for the entire row. So I'd do one I/O. And by the way, if you've ever been around databases for any period of time, the most expensive operation in any data processing world is I/O. The amount of times I sat there and did analysis on database queries and trying to figure out what was actually taking the time, it was CPU waiting on I/O. Anyway, I digress. So awesome for transaction processing when you store your data together in a block, but as soon as you start doing analytics and say, look, I want to sum all of the values, which makes no sense in this query because you do not sum currencies from different currency types, but ignore that. It's really the goal here is that If I'm wanting to get the sum of values, essentially an aggregate, this is an analytical query, I'm having to actually do multiple IOs, so the expense of that operation goes up. The alternative is to, of course, store it by column. So let's go put all of the ID together in one block. Block 2 is all in another column, and column 3 is all in another block. So now let's look at this through the lens of analytics. Obviously, if I want to do that sum, I've got one IO to do, happy days. But as soon as I want to do transaction processing, I'm back to multiple IOs. Now, this is extremely technical, but it's fundamental to database architecture and whether or not you are operating in transaction worlds or analytical worlds. So that question was so key, right? What's your new database? And what we ended up doing is we would create two databases. I'd have a transaction type architecture with a small block size, or an analytical database with a really big block size so I can pack as much data that needed to be queried together as possible. And we all know the architecture, right? The business process would write to table A and B, transact against that data, and of course we'd then haul that data out and load it into our data warehouse, do some joins, aggregate, and analyze. Happy days. So that was the world which I grew up in, and it kind of has carried on that way. And we've ended up with this kind of interesting split where we've got our transaction processing team sitting completely independent of our analytical team, and the two worlds have kind of had this wall between them, which is not where we want to be. We really need to start thinking more about how do we actually start bringing these two systems together, because we're in a much more symbiotic space. What we do in the transacting world and what we're doing in the analytical world are much more tightly coupled than they have historically been. We are moving to what's called HTAP, hybrid transaction analytical processing, or translytics, running transactions and analytics in a continuous virtuous loop, because one feeds on the other. So it's got to go both ways, and that's really what we've got to think about. So this is kind of, I guess, the setting of Lakebase and why Databricks is kind of moving into this space, because there are so many use cases we're seeing with customers that are doing stuff in Databricks where there is a transactional requirement that the user population needs to be able to access data in very low latency speeds, and there's lots of people doing it concurrently, and we need to protect things like ACID and all of those cool database theories which aren't historically the foundational requirement of an analytical system. Transactional systems are optimized for that. So from that perspective, we're seeing a lot of customers take the data, the insights that they generate inside Lakehouse, and move it across to a transactional database, or at least try to. So what we really want to do is democratize intelligence to the business in a way that makes the most sense for them. So that's kind of the goal where we're going with this. So applications, as we know, have evolved quite heavily. You know, we're seeing them move into a more of a serverless architecture, this concept of stateless, and they're getting more and more intelligent as we infuse AI into them. But traditional databases, I would argue, have not changed a heck of a lot since I was first working with Oracle in 1990, which, by the way, started life in the mid-70s. The architecture has moved around a little bit, but fundamentally there's these monolithic systems. You know, if you start looking at databases and start thinking about them through the lens of how we develop code, the database isn't in lockstep with the actual development cycles. They are not cheap to manage just because of the tightly coupled architectures that we have and the very proprietary architectures that we've historically seen. And we end up locking ourselves into particular database flavors because the whole application is predicated on the features that database has, and we kind of work to that monolith. Hard to get out of, they're quite sticky. And agents are compounding the problem, because if you look at the requirements of agents and things like maintaining state and the ability to speed up the activation of databases and shut them down, it's just not really designed to meet the current requirements. So as I said, the fundamental problem is this: we've got our storage compute tightly coupled. That means everything has to grow together and shrink together. And licensing is not really optimized for this new world. So these are kind of the problems. And you multiply that out, and you end up with siloed databases all over the place. Somehow you've got to integrate, get a single view of the whole business. It's heaps of fun. So into this arena, we brought Lakebase, which first of all starts off by taking the same concepts that we have done with the data lake and splitting the storage from the compute. So that means we can scale the compute layer independently of the amount of data in the platform. And this is a very important architectural change because it allows us to now start and stop a OLTP database in sub-second and scale as the users require it and shrink as the users require it, very much following the paradigm of Lakehouse. So Lakebase is taking the best features of data lakes, combining with the best features of traditional databases, hence the name Lakebase. So just so we are clear as to where the name Lakebase has come from. Technically, it's Postgres. Now, Postgres has been around since the mid-90s, so it's even older than me when it comes to database experience. And just FYI, Postgres is actually the successor to Ingress, hence the word Postgres, just in case anybody wanted to know where this Postgres comes. And it's now the fastest growing open source database by far compared to any other in the market. But anyway, that's our first key decision, was to make the serverless architecture come to this space and separate storage and compute. So, and what I'm going to hopefully show you when we get to the demos, as long as my demos, which are all live, not pre-recorded, so I'm opening myself up for massive failure in front of a group of people, but we're going to show you some of the features we put in this to try and address what are needed by database developers and start thinking about how this could be used within your organizations as you democratize data in a completely different way. Key is obviously keeping the costs low, so it's a consumption-based model, not a user-based model or tied to the CPU that you have, because typical databases, historically, when I was at Oracle, you license the high watermark. How many cores does this database have to play with? If I'm using 2 of them out of 10, I'm paying for 10. It was always that sort of model, which was awesome if you're an account manager. You always license the high watermark once a year requirement, but majority of the time they were spending 80% of their money on doing nothing. And it's got to integrate with the wider architecture, because one of the things that we see inside traditional databases, OLTP databases, and what we see in Databricks are the same. You've still got governance requirements, you still need to bring data in and out, you've got to secure everything, right? So there's a lot of complementary requirements in OLTP that we had already solved in Databricks. So we'll see that too. So just really quickly, we'll go through some concepts and then I'll show, not just how. So there's this concept of branching, and this is really probably one of the most important features that we've put into Lakebase. I can instantly snapshot a copy of my production branch to have a dev branch. And what it does is it then does what's called copy on write. So any updates to the dev branch have their own version of the data, but anything that's still the same as production keeps reading the production version of the data, and production builds its own subsequent branch. Why is this important? If you think about how applications get developed, you take snapshots of the code, but the code needs to be in lockstep with the data. And historically, we have not had a really easy way to snapshot the database at a particular point in time relative to the code. And if you think about the other part of this is when you do your final production pre-test, you typically are doing that on some horrible copy that you created 6 years ago that has kind of gone off in a very different direction to real production. And when you go to roll out your code into production, it crashes, it burns, it doesn't work because there are nuances in production that just aren't present in your pre-production release copy. If I snapshot literally the day before my current production system and do my test against that, then I know I can go into production with confidence. So we're thinking about this from the developer experience as our primary target audience. So if you're in the database world, you'll be very familiar with the headaches of trying to push code into production and having a nice, safe place to develop and test. So we'll show you the branching and how it works, and it's instant. I literally hit branch and it's there straight away. There's no waiting. And therefore I can work with my Git code repositories and concept with my database. And once everything's finished, I can blow them away. It's ephemeral, so it disappears. We don't have anything hanging around that didn't need to be there, so there's no risk from a security point of view. It uses a very similar concept for backup. It does have this nice snapshotting ability, and I can sort of like do time travel on the system. I can go back to, I think, 30 days back if I want to and do point-in-time recoveries. I can back up the whole database to files and take them offline, so all of those usual things. So kind of uses that branching technology. Scaling is instant. This is this idea of adding more CPU, because we've separated compute from storage, adding more CPU and memory as user requirements increase, scale it up, scale it down. So we're always meeting what you need. You only pay for what you are using. So none of this high watermark purchase anymore. And then, as I said, this whole idea of shutting the system down when you're no longer using it. So this, by default, I think it's like if it hasn't been touched for 5 minutes, it will turn off. Then it will turn back on in a second. So it's pretty quick, and you can change that to stay on all the time or to shut down within 60 seconds of no use. In terms of concurrency, one of the key architectural requirements in a traditional database is the readers and the writers. And we have this ability to separate readers from writers with different types of compute. So if you're just going and doing a query, we can keep their load isolated from the writer's load. And that just means concurrency is a lot easier to manage if we're separating that. So we've got compute ring-fenced for the reader versus the reader-writer. So that just makes it more performant. And it's tightly integrated with Databricks, this traditional lake house part of the architecture. We share the same storage. So when we start getting into governance and management of everything, there's a lot of tight coupling there, and I'll show that in the demo. So what are we doing with these things? The first one is your traditional application database architecture, things that, this is what I was doing when I was at Oracle. Standing up a database, I wasn't thinking about the analytics requirements. I was just building an application that could run on a database. It needed a database. You do not put databases in just for fun. They are obviously the back end, the persistence layer of the app. So between Databricks Apps and Lakebase, we've got this really nice ability to build standalone applications. And one of the use cases, you can build whatever you want with it, but state for agents are a really interesting one, where agents are now able to spin up this whole architecture instantly, keep the conversation state tracked in the database, and when the conversation's finished, blow it away because it's variable. So this is a really important scenario we're seeing with agents requiring instant databases, and we're seeing more than half of the databases that have been spun up within Databricks, lake-based databases, have been done so through AI agents that are requiring a state database in the back end. So not even humans are creating them. So they're there for about 5 minutes and then gone. So really fast turnaround. Then we get into these architectures that start to think about it through the lens of how Databricks, Lakehouse, and Lakebase work in concert. So here we've got a scenario where I am in Lakebase as my transaction system, and I'm pushing data into my data warehouse, into my Lakehouse for analytics. Very traditional architecture, but Databricks does all of the coupling, which is the key. We've provided, and I'll show you how easy it is to bring tables that are in Lakebase into an analytical arena. But it goes the other way, right? This is what I was talking about before, that there's a lot of use cases where customers are pushing their machine learning model predictions, for example, out to a transactional system for serving. So from that perspective, there's a lot of those very bespoke use cases where you need to serve analytical data to an audience that is going to consume it in a transactional way. So that's another one. So the architecture has now been updated. So you've got your data layer, you need to catalog across your data, so everything is governed. Agent Bricks is now sitting across that. This is kind of like the engine room that sits on top of Unity Catalog to make sure that we are serving contextually relevant data to all of the various upper levels. So that's the Genie code capability. So if you come tomorrow, we'll talk a little bit more about these things. And obviously Agent Bricks, which is our ability to build knowledge agents and supervisors and agentic architectures and so forth. Then you've got Lakeflow for ingestion, Databricks SQL, which has been around for ages, our data warehousing engine, and now Lakebase is our transaction database, and then over the top of that, apps, which I'll show an app shortly, and then our traditional consumption endpoint, which is Genie and dashboarding. So this is kind of the reference architecture, but the end user is going to hit the top layer predominantly, use the lower levels for actually processing, and then talk down to the data. So that's the theory over. Who has never seen Databricks before? All right, we're on to the same. So everybody's familiar with a screen that looks something like this, right? This is home page on Databricks. So what I want to do is I want to sort of show you how Lakebase is fully managed by Databricks, how you can launch it, scale it down, branch it, and so on. So what I'm going to do is I'm going to use this thing called the app switcher. So hopefully people have seen the app switcher. This lets me switch between Lakehouse, Databricks 1, and now you can see if you've got it, Lakebase Postgres sitting there in the bottom corner. I think there'll be others coming soon to this space, but for now that's what we've got. So what I want to do is I'm going to go to Lakebase Postgres, which is the switcher that brings us out of the standard environment into specifically the environment for building lake-based databases. Now, I've got one I've already created, which we'll go into a little bit later on, but let's just show you how we would create one from scratch and how quickly they are to create. So I'm going to create a project, give it a name, so my demo DB, give it a project name, pick your version, which at the moment is either 17 or 16. 18 is not far away, and it comes with a predefined size, but you can change it post creation, and you can set the templates back end to be different. If you've got serverless policies, you would go and configure those, and if you've got region choices, you would pick those, but in this case, there is just the one. So I can now hit create, and fingers crossed it behaves itself, and that database is now running. So from not having a database to running was literally a second. What do we got in here? Well, it's an empty database, of course. Just quickly, you've got the ability to muck around with things like some of the settings. So I've got my demo DB here, and I've got my production branch, which is the default branch that I'm coding in. And I can go in here and make various changes. I can change the compute. I can set my window for restore from the defaults. Obviously, permissions is a really important part of it. Connections, so how am I going to connect to this database? There's multiple ways to authenticate, so what am I going to allow? And if I'm going to take snapshots on a periodic basis, because I might want to say I'm always going to roll back to midnight, for example, so I want a nice easy snapshot to find rather than doing point-in-time recovery type things. And I can get rid of it, so nothing terribly amazing there. So if we go to tables, we should see nothing. There'll be no tables. If there are tables, I'll be staggered because I didn't create any. So no tables, right? Zero tables in the public schema. So how easy is it to create a table? Well, I can jump into the SQL editor, and here I've got, fortunately for me, a pre-canned query that they give us, which is pretty straightforward. Create a table if it doesn't exist, playing with Lakebase with 3 columns. And then it inserts into that table some random data and then gives me a select. So let's go and run that query. Actually, it's 3 statements. So I should get 3 statements come out. First one, created, worked okay, statement executed successfully, insert 10 rows, statement successfully, and then the select 10, and there's my 10 rows. So if I now go back into tables, we should now have a table playing with Lakebase. There we go. So there's my data. So that's kind of, nothing fancy. It's just creating tables, right? So that's nothing to get too excited about. But what I might do now, and remember there's 10 rows in this table, let's go and create a branch. And what we'll do is we'll go and muck around with the branch, and then what we'll show is the branch compared to the original and how that you can make changes to one and not disrupt the other. So I want to create a new branch. So give it a name, just call it dev, whatever you want to call it. These things can be set to expire. In this case here, it's just defaulting to 1 day. And you can choose where do you want to create your branch from. So this is important, right? On the basis that right now it'll snapshot what the data is there right now. But if I wanted to say there's a specific point in time where maybe there was a corruption in production and I want to go back to just before that and go and have a look at it and see if I can replay that, I can go and time travel and set my query, my branch up based on that. So let's create it based on the current data because I've got a table with 10 records in it. And it's giving me the connection details. So if I want to actually connect to it through a third-party tool, which is what you'll always do because you're not going to typically work with databases down at this level, I've now got my child branch has now been created. So if I go back in here, I should see 2 branches. So I've got my dev branch and I've got my production branch. So under dev, it should be identical. I've got 1 table. Fingers crossed, playing with Lakebase. So if I now go back to my SQL query, let's go and run the same statement. Now, the first one is create or replace if not exists. So the first statement should just skip because the table exists, but it should do an insert of 10 more records. And then if I go select star, I should get 20, fingers crossed. The scary thing about doing live demos, it worked every time I did it yesterday. So let's see. Oh, look at that. We now have 20 records in the table. So that inserted. But before we jump back to the first branch, to the production branch, there's one other thing I will do. I'm just going to change this and let's put in another table, because what I do want to do is let's call it _2 and we'll insert into table _2 and we'll do a select star from _2. What I'm doing is I'm creating a second table, and why this matters is when you start to compare branches, and you can actually do that within the system. This is fun, isn't it? Are we enjoying ourselves watching me create tables?
Go Barry.
Trust me, when I was at Oracle, this is the stuff I lived for. I still live for it. Yes, I know, sad. All right, so that all worked. 10 records. Now I should have 2 tables. Fingers crossed. So playing with Lakebase and playing with Lakebase 2. Happy days. So now if I want to go and have a look at the original branch, make sure I haven't corrupted that. If I jump back into production, I should see just the one table. So that's branching. Very unexciting, but that's the way you want it, and very easy to do. But you saw how quickly those branches created instantly, and off you go. And you can sub-nest branches. I can create branches on branches. So you could create a development branch and then have, this is developer 1's branch, and they're doing their bit of coding, and this one is developer 2. And I can refresh a branch from its parent to get the latest versions pulled through. That said, you wouldn't typically use branching. You can't like take the code that is, if we go to branches and have a look at the two. So let's go and compare production and dev. So if I go compare to parent, actually we'll go to the one above, compare to parent. Oop, where was I? Compare. So I got my production branch and my dev branch. I'm not going to use this as the method to actually promote changes. I would do that through standard code into CI/CD. You'd have your create table scripts, update tables. The one thing that you're not comparing is data. I'm just comparing structure, the DDL, the data definition language. So here's everything that's in the original one, and then you can see here I've added in table number 2, and there's a bunch of things that are going on behind the scenes. So that is an exciting tour of doing a database creation, but let's go and make this a little bit more useful in terms of looking at it through the lens of an application. So branches I have talked about. Let's go back to, get off that. And if I go back up to Lakebase Postgres, I've got my new DemoDB, which I created. I've created another database called Water Authority Tracking. Now, this is not designed to resemble anything in reality. This is just purely coincidental. So if you recognize anything and it feels like it's actually based on reality, it's not. I'm just picking on Water Authority because they are a public entity, but also a utility. And I thought there's a possibility I might have a combination of that in this room. So I'm trying to find a use case I could have that kind of talks to both of those organizations. Now, this is a database I pre-created. And if we go and have a look at the tables under this system, we have got 4 tables and a bunch of views. I'll get rid of the views just so we can see what the tables look like. So you can see I've got an assets table, and you can see I've got a bunch of assets spread around the country, pumping stations, water mains, reservoirs, yada, 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 stuff that transactional databases would record. I've got incidents, inspections, and maintenance history. So just, again, it's a transactional database data set. So that's all happy days. Now, what I want to do is kind of give you the sense of what's going on with this application that I'm going to show you, and how it all works very tightly with Databricks, which is my ultimate goal here, is to show how easy it is to have this bi-directional play between Databricks and Lakebase. What I'm going to build in my demo is this. I've got an application I have created with Databricks Apps, which you'll see very shortly. And what you'll be doing as a field worker is you'll be looking at assets, you'll be going out on site and recording observations, recording incidents, maintenance activities, and so forth. This is backed on to a Lakebase database, one we just saw those 4 tables in. This in turn, though, is going to be tightly coupled with Databricks, because we also need to provide real-time analytics to the back-end team so they can keep track on what's going on. And of course, they're going to consume all of this through the various interfaces in Databricks, whether it's through a dashboard or through a SQL query or through Genie. All of those are options. So we'll do that in this demo. Okay, so let's get out of that and go back into here. Right, what I need to do now is I need to go back to my Databricks one, because this is where the business spends their life. They don't go into Databricks. They are business users. They aren't going to bury themselves in that space. They are going to start in Databricks one, which is our UI for business users, where they can see Databricks apps, Genie rooms, and dashboards. And I've created Wellington Water app. So let's go and open up Wellington Water app. Don't get too hung up on this. This is something I knocked together in a fairly short amount of time. I haven't had it actually field tested by anybody, so it may actually not work, but that's not the point. I've got a bunch of assets you can see here spread around the country, around the region. This is Wellington, not the world. And I can sit here and say, like, I can click on this one up here in Tawa, and it's an offline pumping station. And here in Karori, I've got a degraded water valve and so on. So just a high level, I can go and filter. So standard Databricks app stuff, showing the data that's sitting in that transactional database rendered here on a map. Where I want to really go with this is I want to go into my asset registry. So I've got all of my assets, and as you saw in my fictitious data set, I've got 100 assets under management, 18 are requiring attention and 4 are offline. So that asset registry sits in the back end here, and I am going to bring up one asset I know is a problem, which is the Karori DS5 asset. So we'll pull that up. So it filters for everything with Karori. Here are the 4 assets in Karori, and I'm going to specifically analyze the Karori PS5 application, which is currently offline. And what I've got down here are things like, what are the asset details pulled from that asset table. I've got previously recorded inspections. What have we done in the past from an inspection point of view? We have logged maintenance activities, and obviously we've got incidents against this particular asset over time. So that's at a high level. What I want to now do is sort of do some analysis on this. Let's go back to an analyst's point of view before we actually start doing anything within there. If I go back to Databricks 1, and this time I'm going to jump into Genie. And what I want to do is, well, actually, before I go to Genie, let's just show you. I mean, obviously, one of the key things inside Databricks is not just your standard Genie interfaces, which aren't standard at all because they're quite new. Are these things, right? Dashboards. So we build dashboards all the time. So this is a Databricks dashboard built on the data that we are looking at in the transactional database. So you've got your total assets and so on and what type they are. So standard analytical stuff. Now, all the data that we are looking at here is based on those 4 tables that are in that Lakebase database. And I need to show you how those tables have been made available to Databricks to actually build this dashboard on. But at the same time, I've also done the same with Genie. So if I go into the Wellington Water Authority database, and if I go to configure, has anyone not seen Genie? Is probably the easier question now because we've been showing this for a while. You've not seen Genie? Okay, so Genie is our talk to your data interface. So I've got here just a ask your question type API. In the configuration of this, there is a whole bunch of tables. So there's a lot of setup that we can go through, but we won't go into the details of that beyond saying, look, I've got those same 4 tables available to Genie. So any question I ask is going to be contextually constrained to these tables. So my assets tables and so on. So let's get rid of that. And I've pre-loaded some questions and say, okay, well, what is it about the Karori asset? And what I'm going to do, I've got this in agent mode. There's 2 modes. I can talk to my data, which is effectively turn that into a query, which will then go find the data and just pull out a result set and maybe do some very low level interpretation of what it sees in the result set. So Genie is turning questions into SQL statements and then running them against the database. But agent mode, which we've introduced really recently, allows us to do deep research. Now, this one takes a while, so I should have actually started the question first before I started to explain all of this. The question is, what is it about the asset Karori PS5 that may be contributing to its offline status, and what could we have done better to have prevented this maintenance? The sort of question a business user is going to ask, but they want to do it based on the data that's sitting in behind the tables. So it's going through a reasoning process. It's having to think, right, I'm going to look at this. Let's go and actually expand the logic. Okay, 4 things I've done. I've gone and looked at the current status of the Karori PS5 asset, looking now at its incident history, the inspections, and maintenance. And now it's trying to digest that. And then in a bit, it will eventually say, okay, what's the next step I need to do? Because at the end of the day, I'm trying to answer this question. What's the plan? So now let me analyze some potential warning signs that we could have seen to have prevented this. So, what's the maintenance type breakdown? Comparison to other pumping stations, so it's done a relativity check. What preventative maintenance has been done on this asset relative to other assets, and so on. So it's now working its way through that. Now it's running some queries to get the condition score and understand that preventative maintenance. Eventually, once it finishes all of this working, it's going to come out with here is my full report. Fingers crossed. So again, this is live queries, so we just have to be patient with how they work. But I suppose if you think about how much time I'm spending here, yes, it's a couple of minutes to kind of tap dance. But in reality, the amount of work that we're getting through compared to how you would do this in another historic way would be relatively massively sped up.
Coming from the business context, where I see this used quite a bit is also like human resources. So if you think of you're having a C-suite or senior level meeting and you have a dashboard you're pretty chuffed about, and CE asks one question, great, you're able to ask that one question. But as soon as they dive a little deeper and your answer is, oh, I don't have a dashboard for that, you have the data, but maybe you don't have it immediately. So this notion of having a couple arenas kind of stitched together is where I've seen it used most often.
Build your own dashboard on the fly.
Yeah.
Because this sits alongside as an accompanying capability to dashboards. By the way, dashboards have got Genie embedded in them as well. So you can ask questions directly in the dashboard, but this is in a dedicated Genie space. So it's come back and said, due to the fact that we had a bearing failure, bit of a root cause analysis, some warning signs, we didn't do maintenance when we should have, what could have we done better, and so on. So it's just providing a report. So that's not part of the Lakebase demo, other than to say that the data that this is based on Lakebase. But there is one other question I want to do, just to show you how this works in terms of real time. We'll go and ask a new question, and I've preloaded these questions. Where is it? Visualize, tell me and it's not showing me like questions, so I'm going to go and steal them from somewhere else. I did fortunately pre-capture one of the questions. What are I want to know what was the most recent inspection against this asset. So let's just put this back on. Actually, we'll leave it on agent mode. I'll go to chat. Chat should be quicker. It's just going to say, well, it's now going to look for the inspection data and bring up the pet. So what I'm going to do is going to come back and run this query again in a minute. So it's pulling up asset number 5, and it says there that D. Patel on the 14th of August did some maintenance on it. Okay, so that's the last inspection, I should say, not maintenance. Right, let's go back into my app, and I'm going to log an inspection. So new inspection, it's got today's date. I'm going to bring the condition score down. It's going to hopefully say it's now been updated to not so flash. Come on, poor. Put my name, B.Hodges, and go, this is a piece of whatever. All right, and action is required. So submit the inspection. So that's now, fingers crossed my app doesn't crash. And now if I go back to my Databricks 1 query and we rerun that same query, I'll grab it this time and we'll actually run it in a totally, so you can see it was D. Patel in August. And remember, I'm in Databricks, not in Lakebase here, at least architecturally. And we're going for time, 10 minutes. We should be okay, because this is probably getting close to the last thing I want to show. So we're rerunning the query. And hopefully we don't see D Patel, we see B Hodges. And it's not going to give me the latest one. There we go. Try that again. I might just do this in a completely new. There we go. This is live demos for you. Now it's not going to behave. Now it should rerun the query. It's the thing. It shouldn't cache the last one. That's what I think might have happened there. But it should go and throw it. I think I did save it, didn't I? I know what I'm doing. Oh, there, that's pulled it through. That's pulled it through now. So it just took a moment to actually get the. I think it was probably more a caching issue in that particular case where it pulled it through. But the point is that update has moved straight into Lakehouse straight away. So how's this all working? All right, let's get out of that. Let's go back to our favorite place to be, which is directly in Databricks. And what I have in here, if I go into Unity Catalog and we search for water, and I've got here my Water Authority Lakebase. So if I look under there and look under the public schema, I've got all those views, but I've got the tables, right? Assets, and if I go to incident log, inspection log, I think. Inspections? It was inspections, wasn't it? Sample data. This probably won't pick it up because this only caches the top so many rows. So we won't see it. It's only like the top 100 records, I think, from memory. But that's the data. But what is this table? If we go look at the table, this table is a foreign table. What I have done, if I actually go and create a new catalog, I create a name, give it a name, but the type here is to call it a lake-based Postgres table, pick my database, so my water asset one, pick my branch that I want to pull from in my database, water activity. And what that does is it's just creating a federated pointer back to Lakebase. So because all the data is shared physically on the same storage, it can see it in place. So we don't have to copy the data. It's just got a logical pointer. So in Unity Catalog, it's gotten and created the metadata of the tables, and any queries it's sent to the metadata of the tables, but the queries are then going to the same files that Lakebase is maintained under the back end. Does that make sense? So no duplication of data, which is really key. And that sort of answers that architecture of how do we bring lake-based data into Lakehouse. We just federate it, and Databricks does it very quickly just through this create new catalog, and we can govern it through that. There is one last thing I will show that under another schema I've created, you can reverse this whole topology. So I've got this other table called water quality readings. This is in Databricks, and I want to make this table available in Lakebase. So really simple job to do. I go and create what's called a synced table. I give it a name here. Actually, what I'll do is I'll cancel out of that. I'm going to copy this because I'm not going to try and type this in front of everybody. Give it a name. So let's create a synced table. So just bear in mind, I'm in Databricks. I've got a table local to Databricks, which may have come from somewhere else. And I now want to copy this table in Lakebase because I want to, for some reason, have real-time information from Databricks provided in my OLTP system. So I've got to give it a name. Now this table gets created in Databricks, not in Lakebase, but it gets then cloned in real time into Lakebase. There's this concept of auto scaling and provision. Provision's the old way we used to do it. Auto scaling is now how we do it by default. Provision, you just have to set the size of your database and it was logged. Auto scaling means it scales up, down. So we're kind of going to deprecate out provisioned. So where am I sending it? I want to send it to my water authority tracking. I've got to pick the branch I want to write it into. And then I've got to pick how am I going to replicate it. Is it once off, or am I going to set it up as a continuous feed? And am I going to do it as a snapshot or triggered? So you just got to think about how often is the data getting refreshed into there. So we'll just do a one-off. It builds a pipeline in the back end. Hit create. And I've missed something. What have I missed? Logical database must be, forgot my database. Water authority. Go do it. Do it. I'm running out of time. Got 5 minutes. Go. This is the last thing I promise. All right, so that's now created a sync table and it's going to set up a pipeline. So we'll just give it a chance to actually do the sync. Whilst that's happening, let's jump across to that back into Postgres. And it should hopefully have started to build the table. So we go to tables. And we change it from water authority. It hasn't started to pull it through yet. There it is there. And there's the table. So the 10 records that were in the table. So now I've got this table synced into Lakebase. So you saw those pictures I showed before. Back in here, I have demoed these two, right? The first one I showed was Lakebase to Lakehouse through that federated catalog. And then I just did the second one, which was a sync from Lakehouse into Lakebase. So in conclusion, over 2,000 customers already using this. It's only been out for a pretty short amount of time, but the interest in it is really high for anybody who's traditionally done anything with Postgres. They've stood them up independently. They can now just fire them up because they're part of the Databricks stack. The consumption is just part of the final billing, so it's easy. There are 3 customer stories here. I won't go into any detail other than they've all got the same problem. They had multiple setups of independent OLTP databases completely decoupled in any integrated way with their analytics. So Athena used to run tankers around the world. I think they're all parked somewhere at the moment waiting to get access to the Strait. But they have consolidated everything onto Lakebase Lakehouse. So same with Quantum Capital Group, who do energy investment management, same idea. All of these stories are the same, simplifying their landscape significantly and getting massive return in terms of productivity and cost savings. And this health organization who consolidated 15 data sets. I suppose the final slide is, go and Google Lakebase. And I'm not sure what the best starting point is in terms of use cases. It will be a look at where you're currently using transactional databases that need that type coupling, or if there are serving needs. If you're in the AI space, we can certainly come down and help out with that.
I always learned so much from Barry. That was a really fun one to properly pay attention to. So thank you, Barry. Really appreciate it. Please, this technical deep dive stemmed from folks providing feedback of wanting to get more into the nitty gritty. It's a heck of a lot to keep up with, right? It's a very fast moving and exciting space. It's our explicit JOB to keep up with this. And for you, it's on top of your regular job, right? To keep up with this and be able to amplify within your own organization. So please lean into us. Barry, you look like you're keen to add something.
I just want to make sure they don't leave it taking some more.
Fuel the machine. I say this after every morning, Pete. Put some hot cross buns in your pockets. Take them to colleagues and coworkers. So appreciate you spending a bit of your morning with us.